And I'm going to answer any questions you may have. There are types of integrals. Please help. It's okay if you're wrong. We're discussing. This is how we learn. We are wrong when we discuss it, and we are wrong again, we discuss it, and that's how we learn. There are types of integrals.
2.
Exactly, 2. Very good. And they are indefinite and definite. What type is this? Is it indefinite or is it definite?
Definite.
Careful. It's okay. Remember, the definite means cut in stone or carved in stone.
Indefinite.
Yes. This one is general. So this is indefinite. That's how we learn. What is the answer? How do I find an indefinite integral? And what does it represent?
It's f of x plus c.
Yes. So the notation is the uppercase f of x because this is the antiderivative of this function. In other words, if I differentiate this function, I get that one. Okay. And it represents a family of functions, the most general antiderivative, family of functions, that has this as the derivative with f of x as derivative. Perfect. What type is this one? It's a silly question. Once we know that this is indefinite and they are not the same and there are only 2 types, then we know. What is it?
Definite.
Yes. What would the answer be? Always.
f of x.
Yes, the uppercase f of x and then evaluated from a to b, which will in turn will be f of b minus f of a. Awesome, thank you. And it will always be, will it be a function or it will be actually
Absolute
a number?
function.
Always a number. It
Yes.
is a number. So this is always a number. 15, 35, 99, 22, -5. This one is always a function or a family of functions. But this one will always be, because see, I have a function and I plug in a number, and then I subtract when I plug in another number. So this must be a number. We are evaluating this function at this number and subtract when we evaluated this number. So it will always be a number. This function must be
Continuous.
very good. Thank you very much. If it's not continuous, we cannot write this. Awesome. Now let's start with your questions. Anything you tried, anything you worked on, anything. If not, we'll go back to that 63. Anything you worked on, anything you would like me to help you with, anything. Anyone? I'm opening the book so we can read this problem one more time. So we are in 4.3. And it's on page 415. Oops. So let's read 63 one more time. Where is it? So we can finish it up because we haven't finished it. Actually, 63 was on the previous page. Okay. Here it is. Accumulated sales. Okay, we're given the function that is the marginal or the rate of change of sales. So they're giving us 20 e to t. Nice function, easy to work with. S prime of t, of course, has to have two measurement units, dollars per day. So dollars per day, fine. Find the accumulated sales for the first 5 days. So for the first 5 days, part A, first 5 days. So we will have to integrate from 0 to 5, not from 1 to 5, so that we make sure that 1 is included fully. Okay, so that's what I wanted to make sure that this is clear. So the total sales will be the integral from 0 to 5 from the marginal sales, 20 e to t dt. So can anyone tell us what do we have to write next? I know you're going to say take 20 outside because it's a factor. I will. And now I have to determine, so first of all, is this function continuous on 0 to 5? Because if this function is not continuous on 0 to 5, I'll say I cannot determine this. Do you think it is? Do we remember the graph of e to t or e to x? Here's the graph of e to x. Is this function continuous everywhere? What do you think?
Yes.
Yes, it is continuous everywhere. No jumps, no vertical tangents, nothing, no gaps. So we are safe. We can continue. So which function prime is e to t? Which function we differentiate to get e to t? I know you know. I know everyone knows that. So we have here e to t. Which function I differentiate to get e to t?
E to t.
Of course, e to t. And from 0 to 5. Keep the constant outside. I plug in 5. I get e to 5 to the 5th power minus, when I plug in 0, how much is e to 0?
1.
Exactly 1. And then I will plug this in the graphing calculator and determine the total sales for the first 5 days. So, you know me, I like to plug in the function, but this is just numerical. So e to the 5th power, and then come down from there minus 1, and close. So 2948.26. 2948.26. The second question is what we, by mistake, I read the second one instead of the first one last time. Find the accumulated sales from the beginning of the second day through the 5th one. So this is what we have as the integral from 1 to 5. So in part B, we already calculated this, but I like to have both together. So here we have total sales from 1 to 5. So that will be the integral from 1 to 5 from 20e to t. dt. Nothing changes. The antiderivative is the same. It's still 20e to t, but the limits of integration, these are called limits of integration. This is not LIM, the operator, no. If you don't want to say the limits of integration are 1 to 5, you can say it starts at 1 and it ends at 5. So 1 to 5. We plug in 5, of course 20 stays outside, and we have e to the 5th power minus e to the 1st power. And this is what we got last time. I can copy it from here. What was the number? 2913.90. Good. Any questions? Anyone? Any questions? Any questions? Okay. In that case, I'd like to continue with 4.4. Properties of the definite integral. The definite integral has several properties. We're only going to discuss very few here. In my STEM class, we have 9, 10 properties that we look at. But here, we only look at a few basic ones. So here's number 1. So let's look at the function. The function is continuous. And it is continuous on this interval, AB. Now, can anyone tell us how to express this area? How do I express this area? It's okay if you're wrong, but just try, please. How do we express this area under the graph of f of x between a and b? Give it a shot, please.
Is it 1/2 base times height?
This is it. This is the area.
Okay.
It's the definite integral from a to b from f of x dx. So the integral. This is how we learn. This is our communication helps. So we don't make mistakes later. Awesome. So this area is the integral from a to b from f of x dx. Now imagine that I have a point here, C. So here is one property. Can I express this area as the definite integral from a to c from f of x dx plus the integral from c to b from f of x dx? Will this be the same with the area from a to b from f of x dx? What do you think? The area from a to c is this area. The area from c to b is this area. Is this the same with the area from a to b? What do you think?
Yeah.
Yes. So this is one property of the definite integral. I can split it anywhere I want, in 2 pieces, in as many pieces as you want. I can have this piece plus this piece plus this piece plus, it doesn't matter. So as long as there is no gap, see, there is no gap. A to C, and I start at C to B. So that's one property. Here's the second property. The integral from A to A from f of x dx. What do you think this equals to? Let me give you the graph. Let me show you the graph. So we have the function f of x, and this is from a to a. What do you think this equals to? The integral from a to a, from f of x dx.
0.
Exactly 0, because there is no base. So in other words, the integral from 3 to 3 from 5x dx must be 0, because there is no base. In other words, they said base times height. Yes, for if it's a rectangle, but this is not a rectangle, but it's the same idea because we used rectangles before. So you are absolutely correct when you said base times height, because it's every piece, base times height, plus, 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 right? So it's perfect. So, but here there is no base because there is no distance between 3 and 3. Awesome, very good. Other property, property 3. So let's say now we have two functions. We have function f of x, continuous of course. We have function g of x, continuous of course. Of course, our special a, b. And this time we want to determine the area between these two graphs. So I'm going to call this A. Any suggestions on how to determine this area? Because we are going to look at graphs that have enclosed areas between them. So then we will be interested in determining the area between those two. Okay, so let's say this. Can anyone give us the area under f of x? I want to write the area under f of x. How do I write the area under f of x? So forget about g. Can anyone tell us how to write the area under f of x? We wrote it here. So what is the area under f of x? Anyone would like to tell us? So of course I'm talking about this area now. How do I write the area under f of x? Anyone, please? How did we write here the area under f of x? We said is the definite integral from a to b from f of x dx. This is the entire area. How will I write it here? Can anyone tell us, please?
The definite integral
Yes.
of a to b.
From f of x dx. Very good. Awesome. Minus. Can anyone give us this area? Just this piece.
Is it like minus g of x?
Exactly. The integral from a to b from g of x dx. And yes, you are correct. We don't like to write it. So just take a look for a second. We were interested in determining the area enclosed between these two functions. How do we determine that? We determine the entire area under f of x and we subtract the entire area under g of x to get this area that we denoted by uppercase A. Yes, and Michael is right. We're not going to write this. We normally like to write this. So this is the formula. Good. Okay, so I'd like us to choose and practice these properties. So we are on page, I'll find it in a minute, page 425. 425.